Here we go again. We're going to go over part 2 of 3 of analyzing categorical data. We're going to use two-way tables to calculate 3 types of relative frequencies. First, we're going to have to understand that we're going to compare frequency to relative frequency. The first type we'll cover will be marginal frequency versus marginal relative frequency, then joint frequency versus joint relative frequency. Then we're going to cover relative frequency versus conditional relative frequency. We have to review about probability. So what we want to remember, probability is the number of favorable outcomes divided by the total number of outcomes. A common notation would be the probability of event E here, which is equal to the number of outcomes for E divided by the total outcomes. Sometimes we use S for the sample space. However, we want to remember the event letter, though, can be any capital letter of our choosing, like A or B or anything else. Definition of a two-way table. A two-way table is a table of counts that summarize data on the relationship between two categorical variables for a group of individuals. Two-way tables is sometimes called a contingency table. Do note that we want to focus on two categorical variables. Let's create an example of a two-way table. We're going to arbitrarily take values of 200 people as our individual. Our first category would be drink options with coffee, tea, or other in each of our rows, followed by our second category as time options with morning and evening for our columns. We're going to set up our table as follows. With 50 morning coffee drinkers, 30 morning tea drinkers, 20 morning other drinkers. Then for the evening, we'll have 20 evening coffee drinkers, 50 evening tea drinkers, and 30 evening other drinkers. Now let's talk about marginal frequency. Marginal frequency is the sum of the frequency in a row or a column. So first, what we have here is that we're adding up each of the row. So we have 50 plus 20 giving us 70. Then we have for the T row, 30 plus 50 giving us 80. And for the other row, during the morning, we have 20. And during the evening, we have 30, giving us a total of 50. Similarly, we're going to do this for each of the columns. We'll add up the entire morning column. We're at 50 plus 30 plus 20, giving us 100. Then we're adding up just the entire evening column to give us 20 plus 50 plus 30 to also give us 100. So that this would be the marginal frequency for the morning column and the evening column. And each of the margins can both add up to the total of 200. So let's see what we end up having. For marginal frequency, we added up all the columns to get each of the column totals, and we added up each of the rows to get the row totals, and then we add up all the rows and all the columns margins to get the total. Note that the total of all counts is not labeled as the marginal frequency. This is just the total of individuals. In this case, the number of people. Now I want to look into marginal relative frequency. So marginal relative frequency, sometimes called marginal distribution, gives a percent or proportion of the individual that have specific values of one categorical variable. Let's take a look at an example. Our question here is asking us what percent of people have a morning drink. So the category is morning, and we're looking at the frequency total. So we're looking at the sum of 50, 30, and 20 to give us a total of 100. We're going to have 100 is our morning drink divided by the total number of individuals, which is 200. This simplifies to 1/2, or 0.5, or 50%. Since they're asking the answer to be in a percentage, we want to end our answer as a percentage. So again, we're looking at the marginal frequency for morning, which is 100, divided by the total, which gives us 50%. Let's look at a second example for marginal relative frequency. What proportion of people have a coffee drink? So in this situation, we're going to add up the coffee drinks. So we have 50 plus 20 giving us a total of 70. So what proportion is the coffee drinkers? That would be 70 divided by our total, which simplifies to 7/20. Okay. And this would be a perfectly fine answer as a proportion. To go over again, we're looking at the coffee as our category. We're looking at the total, which is 70, and we're dividing it by 200. We can leave it as 7/20 as our final answer as a proportion. If we also want to write it as a ratio of 0.35, that's also fine. Let's cover joint frequency formally now. Joint frequency is the data entry for a table that tracks the amount for each choice for given categories. Note that the joint frequency is the table we constructed at the very beginning with our arbitrary example with the 200 individuals, in this case the people, our two categories, drinks and time, which is going to be drinks, have the options of coffee, tea, or other, and the time has the options of morning or evening. So the table we've been using and the values we filled in is actually the joint frequency. We're now going to cover joint relative frequency. Since we're talking about a relative statement, we're going to again look at percentages and proportions. In this situation, joint relative frequency is the percent or proportion of individuals that have specific values for one categorical variable and a specific value for another categorical variable. The key takeaway here is the word and. So we're going to look for an overlap of two things. Let's do a couple of problems involving joint relative frequency. Our first question is, what percent of people have a drink in the morning and drinks coffee? We want to look at the word and here. So we're looking at two categories. One is morning. So we're going to look at all the morning category. And we're going to look at the second category as drinks. However, which drink is going to be is coffee. So we're going to have all the coffee drinks. In this situation, the overlap here is the number 50, which is both drinks in the morning and it is coffee. Let's answer this using some probability notation. We're going to state that the morning is the event A, and we have the word and, so it'll be an intersection, and the drink is coffee, so the coffee drink would be our second event, B. So the probability of our event A and B, which is going to be the probability of both morning drinks and coffee, which is going to give us 50 divided by the total amount. In this situation, the total is 200, or 5 over 20, and this would be 1/4, or 25%. Let's quickly go over this problem one more time. What percentage of people have a drink in the morning and drinks coffee? So we first look at the morning as our first category. Then we have the second category, coffee. I'll focus on the word and, which is the overlap out of the total, which is 200. So our overlap of drinks in the morning and drinks coffee is the value 50 divided by our total of 200, giving us again 25%. Let's look at another example with joint relative frequency. The question asks, what proportion of people have an evening drink and does not drink coffee? So if we're looking at not drink coffee, that's referring to others and tea, or tea and others. And this overlaps with the evening drink. So we want to look at the column for evening drink. Then we want to look at not coffee. So that'll be the rows of tea and other. And we're focused on the word and, so that we're looking at the overlap. This gives us our event of 50 plus 30. Then we remind ourselves that the total is still 200. So we're going to take 50 plus 30 divided by 200. So our results would be 80 over 200. And if we simplify this and leave it in the fraction form, 80 over 200 would be 2/5, and that would be the proportion we're looking for. If we want to keep on going and simplifying it all the way down to a ratio as 0.40, that technically also still counts. Now it's time to look at relative frequency. Relative frequency is the ratio of one frequency to the grand total. So here in our data set, all of these are our frequency values. So what we're going to end up doing to each one of these frequency values is divide all of them by the grand total. So we have all the mornings crossover with the coffees, and the evening crossover with the coffees divided by 200. And we're going to do this for all the frequency values in the middle and the inside. Then we're going to also do this for all the marginal frequencies to calculate their relative frequency to the problem. So what we end up having when we're looking at relative frequency is that all the values are now divided by the total. We can take all these divisions and simplify them as percentages or ratios or ratios in their decimal form. And that's relative frequency. We now want to look at conditional relative frequency. Conditional relative frequency is the ratio of a joint relative frequency to the marginal relative frequency, or the condition. Notice that we're talking about the word condition. So this sounds like conditional probability because it is. Conditional probability can be considered the theoretical probability of the conditional relative frequency, or the theoretical version of the conditional relative frequency. Let's look at examples of conditional relative frequency. The question asks us, what percent of people who drinks coffee drink it in the morning? Let's see the same question written in a typical conditional probability version to help us understand. What is the probability that a person drinks coffee in the morning given that they drink coffee? So the given that statement help us determine the condition. Whenever we see the word given that, whatever follows here, we expect this to be the condition. So if we look at the previous statement, where do we see the condition? The first part of the statement, drink coffee, is the condition. So what ends up happening is the row for drinking coffee will become the marginal frequency that we're going to look for. That means 70 will be the denominator value when we calculate our probability. So to figure out what's next, what's the overlap that is, in the morning will be the overlap. So we're going to focus on in the morning, and what will end up happening is that the overlap would be 50. As follows, drinking coffee in the morning. So drinking coffee is our marginal frequency, and in the morning would be our overlap, our quote unquote and statement we're looking for. So what we end up having for our probability would be morning and coffee divided by the total coffee. So that would give us 50 divided by our new total, which is 70. And we can simplify this as 5/7. We can leave our answer in this proportionate form, or since they're asking us for percentages, we will continue simplifying this using a calculator. Using a calculator, we'll be able to estimate our answer to be 71 and 43 hundredths of a percent. Let's go over this problem again one more time to make sure we understand what's going on. At the very, very top here, we've written down the formula for conditional probability. Even though we're using an and statement here, this and statement doesn't necessarily mean an overlap. It really means one after the other. So this is a and then this, and then this, and then this type of situation is how we end up with conditional probability. Let's focus on the condition. It is clear in the second statement form when it is given that they drink coffee. This makes it a lot easier to know what our condition is. So this here would be our condition part, meaning this will be defined as our A statement. when we read sentences that doesn't use the given that formula, we have to essentially consider the first statement to be usually the condition. So when we read the first question here, what percent of people who drinks coffee drinks it in the morning? The condition is already given to us at the very beginning because the way grammar or the way English grammar is constructed. So right here, drinks coffee would be our condition A or event A. Then now that we know what the conditions are, the following events are a lot easier to figure out, meaning our event B. So in the morning would be our event B in either of the situation. What do we have over here though? When we're talking about morning and coffee divided by total coffee, this is actually the probability of B given A. So how did this come from? If we look at the very, very top where we have our conditional probability formula, what we end up doing was solving for our condition probability of probably B given A. So what we end up having here is that when we're saying morning and coffee, this is actually both our events A and B. So morning is actually event B here, okay, followed by coffee, which is our event A. And we're dividing by our total, which is all of the possibility of A. This is how we end up with 50 as our overlap, dividing it by 70, the total. Let's do another example on conditional relative frequency. This time, the question asks, what proportion of people who do not drink coffee have an evening drink? The probability version of the same question would be, what is the probability that a person has an evening drink given that they do not drink coffee? When we're looking at the first question here, we are determining the condition, people who do not drink coffee. If we're unsure why this is the condition, let's think about this. If you were to ask a bunch of your friends if they want to go out for drinks, they have to respond with a yes or no statement. Once you know who wants to go out for drinks, then you have to figure out when. So because we first start asking people if they want to have drinks, this forms the condition. Once we know how many people want to have drinks, then we can figure out the time frame in the evening. So as a result, people who do not drink coffee, this would be the equivalent for our second sentence for the given that statement, that they do not drink coffee. So in both of these situations, we can label these as our events A. That tells us that the time frame in the evening would be our event B. In the evening would be our event B. So we have the following. People who do not drink coffee would be our marginal frequency, include both 80 and 50. The time frame would be in the evening. So our second category would be the evening category in the vertical column. Since the overlap of do not drink coffee and in the evening is T, with 50 in the evening and other with 30 in the evening, we're going to calculate that as 50 plus 30. And we remind ourselves, because we have the given that statement, our new total, meaning the marginal frequency, would be 80 plus 50, which gives us 130 as our new total. So we have the following statement: evening and not coffee divided by total not coffee will equal the evening and the number of tea and others divided by the total tea and others. So we'll end up with 50 plus 30 divided by 80 plus 30, which simplifies to 80 over 130, which gives us the proportion of 8 over 13, which gives us the percentage of 61 and 54 hundredths of a percent. Just to remind ourselves, we're looking for the probability of B given A. Okie doke, let's review our frequency. The first one we're going to look at is marginal frequency. So marginal frequency is essentially our general probability. We're looking for the probability of our event. What ends up happening is the marginal frequency of our event A divided by our total. So in the first example, we're talking about morning drinks. So that was 100 divided by 200. And in our second example, we were looking at drinks that were coffee. So we look across for our coffee. We had a total of 70. So our probability in that situation was 70 over 200. And that's basic marginal frequency. Next up is joint frequency. In joint frequency, we want to think about intersections of statements, meaning an and statement. So what we have here is the probability of A and B, or the probability of A intersect B. When we're looking at joint frequency, our numerator value is the overlap, and our total is still the total frequency. In our first example, we're looking at morning and coffee. So the overlap of both morning time frame and the drink coffee was 50. So this gave us the probability of 50 divided by 200. And in the second example, the overlap we were looking for was evening drinks and not drinking coffee. So in that situation, we had two things to add up for not coffee. It was 50 for tea and 30 for other, divided by still our total of 200, giving us a probability of 80 over 200. And so that's what joint frequency is. We're looking for an and statement that is an overlap. On to our last frequency type, which is conditional relative frequency. In conditional relative frequency, there was probabilities that look like an overlap. However, we want to think about it as not an and statement, but a and then this happened. So one event happened, followed by and then another event, followed by and then another event, followed by and then another event. This is how we get conditional probability. We have one event and then followed by another event. So as a result, we're thinking about a joint frequency of an event B as our numerator value. And what ends up happening for our denominator or our total, we're looking at a marginal frequency. So in our first example, we're looking at drinking coffee and then doing it in the morning. So how probabilities shows us as it is drinking in the morning, given that we are drinking coffee. So as a result, we have 50 as our overlap or and then statement. over a total of 70. In our second example, we want to think about this as we are not drinking coffee, and then we're doing this in the evening. So in terms of a conditional probability, it is in the evening drinks, given that we're not drinking coffee. And so that's how we ended up with 50 plus 30 on top, divided by our total of 80 plus 50 in the denominator, giving us 80 over 130 again. And that's conditional relative frequency. So here's the general overview of our three relative frequency type. It's a good idea to take a screenshot of this or write it down and rewatch this video and to see if things make a lot more sense with this side by side with all of the problems and examples over one more time. Thank you for liking and subscribing. Next time when we come back, we're going to cover the part 3 of analyzing categorical data. We'll be covering side-by-side bar graph and segment bar graphs. But that's it.